Hey guys, so in yesterday's lesson, we started talking about the physical properties of different substances. And we talked about how there is both qualitative and quantitative physical properties. And most of yesterday's lesson, we focused on the qualitative physical properties, so the ones you describe using words like lustrous, or its viscosity, or its color, or its malleability, or ductility, or conductivity, those types of things. Today, we're going to be looking at the quantitative types of physical properties, so the ones that have to do with numbers. So quantitative physical properties are also sometimes called characteristic properties if they're unique. So we're going to be focusing a lot on that in this lesson. Part of those characteristic properties involve things like density. So we're going to be learning about what density is and also how to calculate density and use that to identify a substance. We're also going to look at how particles can behave based on different factors. So again, quantitative physical properties are numeric properties that can be measured. Again, because it is a physical property, you're not changing the chemical composition of the substance. Again, characteristic physical properties are kind of a subset of quantitative physical properties. Characteristic physical properties, again, are numerical, but they are also unique to that substance. So that is what makes density a characteristic physical property, because every different pure substance has its own special unique density. And if I know the density of my substance, I can tell you what that substance is. Not because I have it memorized, but there's a chart where I can look up all the different densities of different pure substances and compare them to my density to identify that pure substance. So density is the amount of matter per unit of volume. Another way of saying that is it is the ratio of mass to volume. And then a kind of simpler way of saying both of those things, it is the amount of stuff in a given space. So anytime you change either volume or mass, you're going to affect the density. So if we look at these circles here, the first two circles have the same volume because they're the same size circle, but the middle circle here has more stuff in it. So more stuff per the same volume. That makes this circle more dense than the one to the left of it. Now, if we compare the middle circle and the last circle here, they both have the same amount of stuff inside, but I have now decreased the volume. So I have less space for that stuff to spread out. So this time, the third circle is the one that is the most dense. Density of gases is highly affected by the temperature and pressure that that gas is experiencing. If you do anything to squeeze the gases closer together, those gas molecules closer together, that is going to increase the density of that gas. So when I put pressure on a gas and I squeeze it into a smaller volume, that is going to increase the density. So an increase in pressure is an increase in density. When molecules heat up, they spread out, and gases do that quite a bit because, again, they don't have those forces of attraction holding them together. So if you increase the temperature of a gas, it is going to spread out a lot. So because of that, if you increase a temperature, you will decrease a density, or vice versa. If you drop the temperature, if you make it colder, those gas molecules come together and condense. So lowering the temperature actually increases the density. Temperature and pressure, again, like I said, really impact gas. They don't have a strong impact on liquids and solids because those forces that are holding the molecules together don't allow like liquids and gases to really spread out and decrease their density like that. So yeah, it's really just gases that we're talking about, pressure and temperature having a major effect on the density. Okay, so the formula for density is density equals mass over volume, or mass divided by volume. You do want to, before you actually plug anything into a formula, make sure you have the right units for everything. So mass has to be measured in grams. Volume can be measured in either milliliters or centimeters cubed. If you are given the mass in kilograms or the volume in liters, you will have to convert to the correct unit first. And you will not be given that conversion. You do have to have your unit conversions for metric units memorized. Once you have all your units in the correct spot, in the correct type of unit, then you can just kind of plug everything into your formula. So let's look through this example here. Okay, so in this case, I'm told that the mass is 10 kilograms and that the sample is 12 by 5 by 8. So that means that my volume is length times width times height. So 12 times 5 times 8, 12 times 5 times 8 is 480 centimeters cubed. Now that works because the centimeters was the unit for the 12 centimeters, 5 centimeters, and 8 centimeters. If those were like in millimeters or something, you would have to convert them before multiplying them to turn them into the volume. I am also going to have to convert my 10 kilograms because I cannot use grams for my mass. I cannot use kilograms for my mass. I have to use grams. So the way we do that is with came, Henry, drank, milk, during, Christmas, mass, or whatever you want to use to remember the order that these come in. This would be for length. So this would be like kilometers, meters, centimeters, milliliters. Because this is grams instead, or weight, this would be kilograms. This would get changed to grams. This would be milligrams at the end there. So maybe King Henry drank Gatorade during Christmas mass. And so because we are in kilograms right now and we want to get to grams, we're going to start here and then we are going to move over to where it says grams. So to do that, I move 1, 2, 3 spaces to the right. So I'm going to take my 10 kilograms. There would be a decimal place right there. And I'm going to move 1, 2, 3 spaces to the right. And then I just put in my zeros for each of those spaces. So my mass is actually 10,000 grams. From there, I can actually calculate my density. So density is mass over volume. So 10,000 grams over 480 centimeters cubed. Which would be 20.83 repeating grams per centimeter cubed as our final answer. Okay, the next question says that the density of a substance is 28.6 grams per milliliter. The volume is 420 milliliters. What is the mass? So this time, our volume is in the correct unit. It's in milliliters. So we just have to go right into our formula. We will plug in the density where the D is. So that is our 28.6. We'll plug in the volume of 420. And then in order to isolate M, we have to move the bottom of this fraction here to the other side. And because this is division, to move something to the other side of the equal sign, we use opposite operations. So the opposite of division is multiplication. So I will multiply by 420. That cancels out. what I do to one side, I must also do to the other, so multiply by 420. And then my final answer will just be 28.6 times 420. So it is 1,212 grams. Okay, and the last type of question is when we have to calculate volume. Again, I'm given my mass in grams, so I don't have to do any unit conversions. I'm just going to start right with my formula. I'm going to plug in my density of 0.103 grams per milliliter. I'm going to plug in my mass of 6.142 grams, and I'm going to solve for volume. Now, the one kind of rule that you need to remember is that anytime you have a fraction like this, where you're dividing, the thing on the bottom, or the thing you're dividing by, has to be the thing to move to the other side whenever you're trying to isolate a variable. Just like we did here, we had to move the 420 to the other side. Well, this time our variable is the thing on the bottom, but it still has to be the thing to move. So I'm going to multiply by v to cancel it out, and also multiply the other side by v. That is going to leave me with 0.103 times v equals 6.142. Now to isolate v, I'm multiplying here. So to isolate v, I'm going to divide, use my opposite operations. I want to get the v alone, so I'm going to divide by the 0.103 to get rid of it, and then I do the same on the other side. So my final answer here will just be 6.142 divided by 0.103, which is 59.63 milliliters. I know that it's in milliliters, by the way, because my density was in grams per milliliter. So because I had milliliters in my density, my volume is in milliliters. If it was grams per centimeters cubed for my density, this would be in centimeters cubed. By the way, you may notice that I don't put my units into my formula as I'm going. That's because I find it confusing to have both units and variables. You have like too many letters. So I am fine if you do that as well, as long as your final answer has its units. But if you would like to put your units in the whole way through, feel free. Okay, I will just flip back to this slide for a second. For those of you that don't like using the formula, you can also use this triangle up here and just keep rearranging it to solve for different variables, whichever one you're more comfortable with. Okay, we will, though, eventually this year get to formulas that are too complex to put into this thing, okay? Okay, the last thing that I wanted to talk about is freezing point, melting point, and boiling point. All three of these are also characteristic physical properties, meaning, again, that they are unique to every pure substance. So if I know the freezing point of a pure substance, I can figure out what that pure substance is, because it will be the only pure substance with that exact freezing point, or melting point, or boiling point. A freezing point is just the temperature that it freezes at, so that a liquid turns into solid. Melting point is the temperature that it goes from solid to liquid, and boiling point is the temperature that it quickly goes from liquid into gas, so the temperature it boils at. There will be a lot of different properties of a substance that will affect its freezing point, melting point, and boiling point. the type of compound, the type of chemical bonds in it, whether or not it's polar, which is something we'll talk about later. But the best thing about these, again, is that we can identify substances using them. So yeah, that is what characteristic physical properties are. They're a type of quantitative physical properties. And yeah, the only calculation you'll have to do for this is a density calculation.